So we're back at the 1600 game. Here is a number of questions we're going to look at in the math section. I'm here with our great math tutor, Yohan Serafimov, and he is a young person that I've known for a few years. We've known each other personally and then professionally. He knows way more about math than I do, and we're going to talk about SAT math questions from his perspective. Before we get started, just tell the folks a little bit about yourself. Tell them, the work that you're doing in school right now. Are you majoring in, what is it again?
Yeah, so I'm Yohan. I major in aerospace, and I'm a junior at the local university here.
Yeah, and you finished your math. I remember being super impressed by the fact that you finished all your math requirements pretty early.
Yeah,
right?
I finished it like my freshman year of college.
Yeah, so you can thank the SAT for keeping you sharp on your math skills, right? Because that's what we're doing. Okay, cool. So we're looking at some questions for SAT practice test 4, and we're doing that because, of course, if you're new to the SAT, you're probably going to go to the first test, and because the College Board doesn't want to make anything easy on you, of course, the first test is practice test number 4. If you're wondering why that is, SAT practice tests 1, 2, and 3 got reused essentially when they relaunched about a year after the digital test went live. They realized there were some issues with 1, 2, and 3. So if you're perplexed by that, there is the answer to your question. That's why we start with practice test 4. And basically, we're going to go through some questions that we've noticed are of interest to students of all different levels. And Yohan, what was the first question you wanted to talk about?
It's question number 2.
Nice. Okay. So question number 2, I'm bringing this up on my screen here. Number 2.
This is starting off easy.
Yeah. Yeah, but I mean, there's still something here, right? Yeah. So do you have the question pulled up? Do you want to read it?
Yeah. It just asks what percentage of 300 is 75.
Yeah.
And I just noticed, because to set up the fraction for the percentage, it's like 75 over 300. But in the question, the order's flipped. So you could easily make a mistake.
Yeah, 75 over 300 is the math. And what you just said, you noticed that because you're strong mathematically. Yeah. But any number of people in high school won't know how to set that up, right? And that's really the big thing about the question is how do you set it up, right? So many times on the SAT, the question is not the math, it's how do I get started?
Yeah.
Right?
Because the math, it's because you're allowed a calculator here. So
yes.
It's simple math.
Totally. And I, no offense to the Desmos bros of the world, but I love Desmos. It's fantastic. But I use that term pejoratively just to kind of speak to people who underestimate what you're going to be asked to do. You're going to be asked to do things that Desmos does not help you turn this into an equation, right? So a lot of people will be like, well, I got Desmos, it's easy now. It's hey, there's some amazing things that calculator can do. You should get well versed in it, but you can't type what percentage of 300 is 75 into Desmos, right? No. So we have to have a framework for that. So let me show you the way that I've talked to students about this. All right, so basically, because the SAT is a game, there's a number of little things that I notice. And this question is immediately the game of translation. Okay. So if you're setting up an equation, and you don't have to set up an equation to do this, but if you are, you basically say, well, the word what, you're going to call that a variable and you're going to call it X. Percent, sometimes I'll break that down for people. I'll say per means divide, miles per hour. And I'll say cent. Of course, cent would mean what would that mean mathematically?
100.
Yeah, exactly.
Something out of 100.
Yeah, exactly. Cent, century and something like that. So percent. So what means X? Percent means divide by 100. Of means multiply. I don't really have a clever way of saying that of means multiply, but of means multiply. Maybe we can come up with something. Then 300. And then the word is means equals. 75, right? So that's a way of setting up that equation. And if you know how to do that game, then this question isn't hard. The setup isn't bad at all, right? And this very quickly translates to, the math you were talking about by dividing both sides by 300. But there's one other thing I might kind of work through here with you is that even without setting up an equation, there's probably some things that we could figure out here. So, if I asked you, if I put you on the spot and said, what, percentage of 300 is 150, I feel like if you stopped and thought about it for a second, it wouldn't be hard for most people to answer that question. Yeah. So what percentage of 300 is 150?
half or
Yeah.
50%.
Yeah, and I love that you said half. Like keeping
Yeah.
it informal is the way to keep the pressure off for
Yeah.
you in the middle of a test. So even instead of percentage, I probably should have said to you, what part of 300 is 150, right?
Yeah.
You would say half, right? So just right there, we can say, well, what part of 300 is this smaller number? Like it's less than 50%.
Yeah, so you know it's A.
Yeah, exactly. You instantly know it's A when you do that. And I'm telling you, like the number of times that the thing that we need to do for smart people is not like help them build an equation, but help them think like a normal person who's out in the world without Desmos, just like walking around.
Yeah.
You know? So, oftentimes estimation over calculation. Right? And the last thing I'll say about this question, and this is huge for like basically every student that we work with, is that if you calculate, you should end with estimation. If you estimate, you should end with calculation, right? Like, what have you noticed before we move on, like just to this point? What have you noticed about like checking your work in all levels of mathematics? Like, tell me about like how that works for you. Like, how do you think about checking your work?
The way I approach it is just to try to find a different way to get the same answer, because both of the ways should agree.
Totally.
And if there's a discrepancy, you obviously know you've went wrong somewhere.
Dude, that's perfect. That's exactly right. That like the number of times that what we have to do is teach people that like you need the flexibility to do things two ways to actually check your work. Because we all know that it feels crazy. I'll like watch young people go to check their work and basically they just do the same thing again.
Yeah.
They feel like it's crazy that I'm asking them to do it in a way. They feel stupid doing it. And they know it's counterproductive, right? So there's all sorts of problems with that. So yeah, like that's why estimation, if you calculated, is the way to check, right? And if you've estimated, maybe you should calculate.
Yeah.
Right? So cool. What was the next question that you were wondering about, Yohan?
It was question number 5.
Yeah, and tell me what, I guess I'll read it here, and then I'm going to ask you to tell me what you notice about the question. So the question reads, well, let me just first make sure that we're all synced up here. This is question number 5. Yeah, so number 5. Hannah deposited a fixed amount into her bank account each month. The function f of t equals 100 plus 25t gives the amount in dollars in Hannah's bank account after t monthly deposits. What is the best interpretation of 25 in this context? And we have 4 answer choices. Just tell me what you noticed on this question that was interesting or challenging, or you can imagine students messing up.
It seems like they throw a lot of words at you, but if you like break down each clause, I guess it gets a lot more simpler.
Totally, I agree. So why don't you do a little bit of that, and I'll tell you how I like talk about this method in a second, but I want to break it down the way that you see fit.
So the first sentence tells you that the following function is representing how much money she has in her bank account at the end of each month. And then you get your function, and then you can easily see that it's a linear function.
Totally.
And then the last question is just asking what is their interpretation of 25, which is next to t, so that's the slope of the function. Nice.
Let me elaborate on that slope idea for a second, okay? So when I teach people this, gosh, I don't know, I don't want to swear on camera. I call it the wise Alec answer method, and usually I use a different word than Alec, but for the social platforms, let's just say the wise Alec answer method. And basically what I mean is like, if you gave really snarky answers to questions over and over again, you would get down to the base level of a question, right?
Yeah.
So if I asked you, what is 25? And you answered, it's a slope, right? And then I said, well, yeah, but what does that mean? And you were like, it's rise over run.
Okay.
And then you just kept going. You were like, all right, well, like, what is the rise here? So what is the change? What is the Y term or the rise? What is the unit that we're talking about for Y?
Well, that would get you back to the first sentence.
Yeah.
The amount of money in her bank account each month.
Yeah, and then the run would be the X, or in this case, the T. And what is the unit for T?
Monthly deposits.
Yeah, so literally now we have dollars per monthly deposit.
Yeah.
Right? So once you know that that's how you could break it down into those small steps like that, you're likely to get the question right.
Yeah.
Right? And one of the huge dangers here is like, you know, having, well-deserved, well-earned confidence, and yet like choosing to move so quickly that you mess that up. Right?
Yeah.
So I want to ask you a related question. So obviously we now know it's the slope. I guess let's just like make sure we can get rid of answers with that in mind here. So like, tell me which answer choices are like most obviously wrong. Let's start there.
I'd say it would be B.
Before she made it. Yeah. So what would that represent in the equation?
It would just, it's saying at like before any deposits. So when t is either t equals 0, it's just negligent.
Yeah.
What would the function equal?
Yeah. Yeah. So like when t is 0, we're talking y-intercept, right?
Yeah.
Now this seems small, but I'm telling you, this is the thing for kids. Like, why might someone mix up the slope and the y-intercept given the arrangement of this equation?
I would just think it's just not like y equals mx plus b.
Exactly.
It's a different form.
Yeah, exactly.
But it's really the same thing.
It's the same thing, but all you have to do is switch that order. And if someone's not very flexible about the information, they go, slope goes first, intercept goes second, right? And they're playing with us in that way, right?
Yeah.
Obviously, we could test that answer by being like, that literally means t is 0. And do we get 25? Of course we don't, right? Yeah. And of course, you could say that about any number of these other answers. Answer choice C is probably the closest in a certain respect because it relates months to dollars in some way, right? And at least it does that. But of course, the right answer is A here. Yeah. So, I mean, I think we've covered basically everything I wanted to notice here. But the big thing is that like these little changes to the equation where you put the y-intercept and the slope in opposite order can easily mess people up.
Yes.
Right. Cool. So yeah, that's the game of like the wise ALEC answer method, which is just break it down painfully small. You can get rid of stuff.
And then with this one, you can still check your work like we were talking about in number 2.
Yeah, tell me more.
Like for example, for C, after one deposit, which is t equals 1, you can just plug it in. And see that it equals 125, not 25.
Totally. Yeah. And that kind of work, I'm telling you, like, so the hardest thing for people, and I wonder, I took the test so long ago that I barely can remember it because I'm so damn old, but like for you, it wasn't that long ago. No. And I remember the first time I met you, actually, I was like, hey man, why didn't you hit me up for SAT prep? Because, I knew your mom and you're basically, I think you said something, I won't make you like repeat yourself, but you said something very much like, I just kind of like looked at it for a little while and I didn't need any help, which is how I was like, okay, so, I'm going to call you to help me out on the other end. But, the fact that, you can just put numbers in there is back to this idea of like, triangulation, like trying your work a different way than you do it. So like, I mean, if it's not too much to ask, when you had to study for the test, and it wasn't that different than it is now, what were the things that you found were like tripping you up that you had to at least correct for, even if they weren't things that, obviously it wasn't that hard. You didn't go calling the person your mom knew as the test prep guy. So
I was just looking at how the questions were formatted. Yes. Because they do try to trick you.
Yes, totally.
I studied for writing the most, just the grammar. Yeah. But if you really you're right, it's like kind of a game. Once you know how they format the questions, you can break it down how they want to break it down, and it becomes a lot easier. Yeah, totally. So what's the next one that you had in mind? It was question number 8.
Question number 8.
Or 9.
9. Okay, sorry. Sweet. All right, so question number 9. Yes, some geometry stuff.
Yeah.
Right? And this is like a big fear for most kids. I mean, I think most people do geometry like years and years before they take the SAT.
Yeah, it's usually in like middle school.
Yeah. And now they're here on the SAT. And I have to always remind people like, it's extremely limited. Like they think of their geometry textbook and all the things they had to memorize, but like this is super limited here. Why don't you read the question for us?
Okay. Right triangles PQR and STR are similar where P corresponds to S. If the measure of angle Q is 18 degrees, what is the measure of angle S?
Yes. Okay. So I think I'm probably seeing the same thing as you, but why don't you tell me, what do you think people are going to mess up most readily here?
I think they would get scared because it's asking about two separate triangles in the same question, kind of. But as soon as you see the word similar, you can really simplify the question.
Totally. So, you know, the other thing is what I sometimes call a eureka mistake. Like one way of explaining this is in terms of triangles. The closest thing. Well, let me go to percentages first. The closest thing to 10% is actually 90%, right? In like a sneaky way, in as much as those two add up to 100%.
Yeah.
Right. So the two portions of something are actually probably closer to each other. Like, you know, 10 is closer to 90 than 89 is.
Yeah.
In the world of percentages. So tell me about answer choices A and B in that context, given, you know, the fact that these triangles are similar.
Yeah, right. So they both add up to 90 degrees. So one of those is a small mistake. Yes. Where you thought about it like the opposite way.
Yes.
So you have a good idea that it's probably not C or D.
Yeah, because those numbers 18 and 72 add up to 90, right? So like there's a high likelihood that one of those is right.
Yeah.
Right. Yeah. And of course, you know, the only difference is that S corresponds not with Q, but with Q's complementary angle.
Yeah.
Right.
And you especially know D's wrong because it's obtuse.
But there is something about D, right? Which I'm sure you can see on second glance. Like, what is the relationship with 18 and 162 that might be relevant?
Oh, it adds up to 180. So
yes. Yeah, exactly.
I see.
Yeah, so like because triangles are 180, that's the other easy mistake. But, you know, we shouldn't discount the fact that like in this case it says not drawn to scale, but I'll oftentimes tell people like if it doesn't say that, you can lean on scale. Like it can't be 162 degree angle, you know, if it doesn't look, you know, more than 90 degrees. It's an acute angle. In this case, I guess it could be, although I still would put money on that not being the right answer based on what I've seen on the test. They're not like they're devious, but they're not like, you know, overtly, you know, messing with you or.
Well, it says it's a right triangle, so you know.
There you go.
None of the angles can be above 90.
Yeah, good. So awesome. Yeah, so with geometry, it's like, you know, basically a small collection of facts about right triangles. That's like, you know, some of the games we teach people are like strategy, and some of them are just knowing like the edges of the field. Yeah. Right. So like the field of geometry is vast, but on the SAT, it's much, much smaller. Yeah. Right? So cool. All right. What was the next one you had in mind?
It was number 10.
10. Cool. All right. So I think number 10 has something to do with, what was it, number 5? We saw earlier, number 10 here.
Similar. It's a linear equation again.
Yeah.
But in a different format than students are used to.
Yes, exactly. Right. So the slope is the second part and the intercept is the first part, the y-intercept.
And it also gives you a scatter plot instead of a simple line.
Yeah, totally.
Because why not?
Yeah, because why not? Because why make it easy, right? And that kind of speaks just like broadly for a second about like what this test is actually intending to do, right? Because like you having done really well in math class in high school, like when you went to apply for college, they knew you were good at math per se, right? So what they're doing with this test is they're attempting to create like an equalizer so that yeah, you're going to have to dig up some old knowledge and you're also going to be flexible about the information, right? Yeah. Because we all know people who like through sheer force of will and maybe great study skills can like keep up with your math classes, but they don't have the flexibility that somebody else might have. Yeah. Right. And those are the kids that the test can expose them a little bit, right? Of course, all this is coachable, so you don't have to be a genius to learn this stuff, but without study, you know, if you're not flexible, you could be in a calculus class and still be scoring a 600 on this thing, right? Or even lower. Yeah. So, okay. So tell me, let's walk through this question. I want to kind of take a comparative view. What are the things that are in play here? Like, let's talk about the changes in the answer choices. What's the first thing that you notice that's the same or in a couple and then different in the other two?
Say the first major split is testing whether you know which one is the slope and which one is the y-intercept.
Yes.
Even though the order's flipped.
Yes, totally. Yeah. And so if we kind of eyeball it, we can certainly say whatever's going on with this graphic, it's kind of like a negative slope. Mm-hmm. It's starting around 10, right? So we could probably cross off answer choices A and B despite the order, right? That 9.4. And again, with your point, like you were saying, like what would be the easy way to confirm that we're looking at the right equation, given points and coordinates given to you on a graph?
I would just look at an extreme case. So at x equals 0.
Yes.
Yeah. You know that y is around 10-ish.
Yeah, you're speaking my language. Yeah, extreme cases. Always go for the extremes. That's the easiest way to check stuff, right? Mm-hmm. Yeah, cool. So then we're down to C and D, and then the only difference is what?
The sign of the slope.
Yes, exactly. And of course, this is the negative side, right?
Yeah.
Now, here's something that I talk about all the time. A sort of meta game that you have to play on the test. I call it test awareness. It's basically like if you see this question in module 2 and you did well in module 1, mm-hmm. and if it's like number 18, it won't be harder to understand. It'll be easier to get wrong. They'll add one extra thing, mm-hmm. which is at the top, they'll say something like, this is the graph of f of x. And then they'll say like, something about how g of x, whatever is a perpendicular line or something like that.
Yeah.
Right. And it'll be not shown. Right. And so you'll have this big graph. And it seems entirely obvious that they're talking about the graph when actually the equation they're looking for is one step removed from the graph. Mm-hmm. Right. So that's like a thing that people run into all the time. So, oftentimes I'll say to somebody, if you find an easy question, like in that location near the end of module 2, like don't freak out. It's still easy, but it's also easy to get wrong. Right. And if you know that, you're good. So sweet, Yohan, what's the next one?
Question 14.
Question 14.
This is just a numerical question. Yeah. It's not even multiple choice.
Yeah. Yeah. And that's a huge challenge right off the bat. Like there's less stuff we can do because we have less stuff to work with.
It can make you more nervous.
Totally.
Even though they're usually as simple as the multiple choice.
Totally. Yeah. So there's, of course, a couple of ways to approach this. But what strikes you as how you might approach this system of equations question?
Well, I was thinking if you're like on a time crunch, since it's only asking for one of the values, which is y, mm-hmm. it would be a lot faster to do elimination rather than substitution.
Nice. Yeah, really smart. Yeah, cool. So like
and
elimination.
They've made the numbers pretty nice.
Yes.
I went through the calculation.
Yeah, and they will very often make the numbers really nice. Mm-hmm. So I'm glad you noticed that, right? So basically we'd probably, I'll do it on the board and you can just kind of walk me through the steps you would take.
Okay.
So what would you do?
So you're asked to find y. So mm-hmm. you would want to eliminate x.
Yes.
And you can see that the bottom equation or equation 2.
Yeah.
If you multiply it by 4, the x's cancel very nicely.
Good. Yeah, good. So then we'd have 24x minus 24x. Mm-hmm. We'd have y minus 4y, mm-hmm. right, for negative 3y. And then we'd have 48 minus, and this is the thing that everyone's going to mess up. Like distribution is danger mode. That doesn't matter like what math class you're in, right? So 4 times 72, what's that, 288? Am I right about that? I think it is.
It should come out to negative 3y equals negative 240.
Negative 240,
but you have the calculator here, so.
All right, so what was the next question you wanted to talk about?
We're on 14?
Yeah, let's do 14. Okay. So, 1 second, just getting my stuff set up. Okay, number 14. All right, so tell me about this question. Tell me what you notice.
So obviously it's not multiple choice,
yes.
which I think can make students nervous, even though the math, it still is pretty simple and should be pretty easy to work out.
Yeah, totally. Yeah, so we have a system of equations. They're asking for the value of y. How would you approach this? There's all sorts of ways you could do systems questions.
Mm-hmm. Well, since you're on a time crunch, it's asking for value of y, which is only one of the two variables.
Mm-hmm.
So using elimination would be
super smart.
A lot faster than substitution.
Yeah, and we won't bother to go into the calculation details for people watching this right now, but like, you know, elimination is a great way. Explain what elimination even means for someone who's confused about that.
It's just kind of taking both of your equations and then manipulating them in some way to cancel out one variable.
Totally. Yeah. And the test loves pattern recognition. Mm-hmm. So they're really keen on, can we reward somebody who recognizes that you know, elimination is better than substitution, right? Substitution is old fashioned, it's good to do, it's tried and true, but elimination is the move here. And over again, systems of equations, the first thing you tell somebody is like, look for the pattern. There's some way in which you can manipulate the equations to use elimination. Mm-hmm. So yeah, really good. And last thing I think we should say about that one is, because there's no answer choices, the thing you said earlier is so important, which is like, once we get a value of y, we should probably just see if it works, right? Like we should probably just like put it into the equations and make sure we get the same value of x. Depending on how fast you're going, you know, maybe you've saved time with elimination, you banked that time, now, you know, cash that check or pull the funds out. My metaphor is getting mixed, but you get the idea. Yeah, checking your work in some ways pretty smart on this question. So what was the next one you had in mind, Yohan?
Number 17.
Number 17, yeah. All right, so why don't you read this question for us, number 17?
Yeah, sure. For a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must the length change to maintain this ratio?
Yes, so this question, of course, if we look at the answer choices, basically there's only two things up for debate. What are the two components that are in play in these answer choices?
It's the length and the width of the rectangle.
Totally. But I mean, even just the language, like it's either increase or decrease.
Right. And then it's either 24.5 or 7.
Yes. And so this question is actually a time penalty or a time reward. Okay. Yeah. So like it's really good to be able to set up this equation, of course, but let's see if we can do this without setting up the equation. Right? So we get this rectangle. We've got a length and width 35 and 10.
So it's not 1-to-1, you know.
Yeah. Yeah.
A certain change in width is going to be a different change in length.
Perfect. Right. So the fact that it's increased by 7 in one direction means that all we know for sure is that it hasn't increased by 7 in the other.
Yeah.
Right. And a lot of folks are pretty uncomfortable with this level of thinking. It doesn't feel like math to some people. Right. So we have to always like remind folks to like bring their intuition, bring your common sense with you to a question. So we've already crossed off 2 answers. Right? And now the only distinction between A and B is the word decrease or increase.
Right. And that one, you can just read it again, and it's a pretty simple, because you know it's increasing by 7.
Yeah.
So therefore, the length also has to increase.
Exactly. Yeah, to maintain its ratio. Good.
Yeah.
And, you know, we can imagine questions in which maybe it decreases. Maybe we're trying to maintain an area. Right? Maybe we have a consistent area, length grows, so we have, you know, sort of indirect variation, right? So we want to be on the lookout for things like that, but particularly knowing where you are in the test. Module 1, probably not. Module 2, as the questions increase in difficulty, you see this question, you may want to just be like, wait a second.
Yeah.
It's easy, but it's also easy to get wrong, right? So going back to my first point, basically we didn't have to do any calculations on this question.
No.
Right? And then you save that time for a question that really requires it. Right? I will say though, for a student who doesn't know how to do that ratio, like that's a game you should know how to play too. It's like learn how to set up these ratios. That's worthy of your time as a student, right? So.
And if you have extra time, you can check your work.
No doubt.
If you feel comfortable setting up the ratio.
Yeah, totally. Yeah. All right. I think you mentioned you want to look at number 16 too, right?
Yeah, 16.
Okay, so let me circle this one, number 16. Why don't you read it for me?
The function f of x, bunch of numbers. I'm not going to read them out.
Yeah, good.
Models the value in dollars of a certain bank account by the end of each year from 1957 through 1972, where x is the number of years after 1957. Which of the following is the best interpretation of f of 5 is approximately equal to 143 in this context.
Yes, and this is the wise ass answer. I mean, the wise Alec answer method.
Yeah, just need to break it down.
Yeah.
And then you can start eliminating.
Good. So
really
we know
quickly.
5 is what?
The time after, number of years after 1957.
Yeah, and as I say all the time to people, like in the real world, of course you could have 5 years and that could represent $5. That could things happen like that all the time. However, on the SAT, the likelihood that 5 is the dollar value when we know for sure it's the time component is almost 0. Right?
Yeah.
So that allows me to cross off answer choice A, which says the value of the bank account is estimated to be $5 greater in 1962 to 1957. But I think, I've heard you talk about this question before, Yohan. You've noticed also something else that like makes that pretty unfeasible. The value of the bank account is $5 greater. Oh, I'm misspeaking. It's not that one that you noticed was unfeasible. Which one did you notice was unfeasible numerically?
It would be option C.
Yeah. So tell me why.
It's saying it's going to get 5. The money in the bank account is going to increase by 5 times in those 5 years.
Yeah.
But if you're comfortable with exponents, you can see that the 1.034 in the equation means it's not going to increase by 5 just in 5 years.
Yeah. Let's talk to people to like help them get comfortable about exponents and like understanding why we feel pretty good that that's not the case, that it's not going to get 5 times bigger when we essentially what we're doing is we take this number 206 and we're going to multiply it by this small number 1.034.
Yeah.
And we're going to do that 5 times. So land the plane for me on like why we both feel very comfortable saying that didn't get 5 times bigger.
Well, to break it down, I mean, 1.03 is pretty close to 1.
Yes.
So you can kind of think about you're multiplying by 1 by 5 times.
Yes, exactly.
So that's going to be still going to grow, but not by 5 times.
Yes, we don't want to discount the power of exponential growth. If you're putting money in your bank account, you're saving, sure, go right ahead. 3% growth's fine. But yeah, we have 3.4% growth. By the way, when I say that, what if somebody doesn't understand what I'm saying? Like, how do you think about converting 1.034 into me saying 3.4% growth? People are going to be confused by that.
Well, I would just ignore the 1 and take the 0.034 out.
Yes.
And that's much easier to connect to 3.4%.
Yeah, exactly. So basically 1 is like 100%.
Yeah.
Right. So we keep that 100% and we're adding basically 3 and a little bit more percent. Yeah, cool. So we've gotten rid of C and we're down to these 2 remaining answers, B and D. So B says the value of the bank account is estimated to be approximately $243 in 1962. And then we have the value of the bank account is estimated to increase by approximately $243 every 5 years between 1957 and 1972. One of those is pretty sneaky, right? So, I mean, like,
it's like the question is saying this function is the value of the bank account.
Yes.
So it's most likely B.
Yes.
Because D is talking about some weird increase per 5 years.
Yes.
Which is not in the question.
Yeah, it's weird. I will say, admittedly for me though, like the distinction between B and D, like I'm more confident that B is right than I think I can see it now, but initially seeing what was wrong with D, right?
Yeah.
So like, let's talk about, I'll say what's wrong with D. What I think is wrong with D. This is saying that every single time 5 years goes by, so that means you raise 1.034 times to the power of 5.
Yeah.
That you're increasing the dollar amount in your account by $243. Again, based on like what you told me.
But that's an increase. It's not the value of the bank account.
Exactly. Very, very good. So it's almost like, a lesser level. Like it's fine if you got to calculate this, but calculating this is once again a time penalty.
Yeah.
Right. Basically, from the sentence and kind of like tell me, I know it feels kind of obvious to say now, but tell me how you know from the sentence without doing a calculation that B is the right answer. Like how you know from the question.
It says the value of the bank account, which is it's equal to 243.
Yes.
So you know that function is $243.
Yes.
And then f of 5, that's 5 years after 1957, 1962.
So the only calculation we really have to do is to add 5 to 1957.
Yeah.
Actually.
Yeah.
Right? So some people might be like, well, I don't know that that's true. I'm going to go calculate. Fair enough. That's one level of the game. But the higher level of the game is saying answer choice B is just another way of saying that there is a point 5, 243, or that f of 5 is 243.
Yeah. Then I just noticed this in C.
Yeah.
That's the only one that says the value in dollars. And the question also says the value in dollars. But then for B, they left that out.
Yes. Yes. Very good.
It's a very weird switch up.
Yeah, well, it's probably, I mean, can you imagine their job, which is like they wake up in the middle of the night inspired to come up with some way of like getting a kid to get this question wrong and therefore not get into their dream school. What a job. But you're right, like little language games like that will mean that if you're not careful, if you're not, actually I should take that back. I hate when people say just be careful.
Mm-hmm.
If you don't have if you don't have a method, if you don't have a plan, if you don't know what you're expecting, then even when you're being careful, you could say, well, that language is perfect.
Yeah.
Right. But I'll actually link this to one other thing, which is on the reading section. I talk to people all the time about mapping. And what I'll say is if you have the exact language from the text in an answer, you should be a little bit dubious of that answer, actually.
Yeah.
The right answer probably, paraphrases, says the same thing in different language, right? But, here we have that same thing happening in a math question.
Yeah, it's weird.
Yeah.
And then A and C also don't have 243 at all.
Yes.
So you can also eliminate them.
Yeah, that's a really good point. No mention of the dollar amount. Yeah. Really good. All right, cool. Well, we've been at it for a while. I'm going to let you go. If you guys want to hang out with me and Yohan and do some SAT math, join us in the mastery program and download the 1600 game. Thank you.